Hi, everyone. Welcome back to section 1.5, part 2. On section 1.5, we were going over parallel lines and perpendicular lines. Let's just refresh our memory. We also talked about point slope form and how to convert a point slope form into slope y-intercept form. We were able to graph the lines like so. We talked about when two slopes of lines are the same, they're parallel lines. When they are negative reciprocal slopes, then you have two perpendicular lines. Now, in the other section, this section covers applications of linear functions. So, following with that, we are going to start working on applications, and we're going to be creating linear functions to model particular data. So let's go ahead and start by reading the question. The local hardware store charges $28 to rent carpet cleaning machine. So let's start highlighting the important information. The hardware stores charge $28 to rent a carpet cleaning machine for 24 hours, so a daily basis. So per day, we know that they're charging $28. And $10.98 for each medium-sized bottle of rug shampoo. So there's two different things. I have the rent, the $28, the rent of the carpet machine per day. And we also have the $10.98 per medium-sized bottle. So that would represent another variable. They're asking letter A, write a linear function S that represents the cost of renting the machine for X days along with 2 bottles of rug shampoo. So what we know is that there's going to be a function in terms of X because X is representing the days. And we know it's $28 per day plus, because the and represents addition, $10.98 for how many bottles? So per bottle, it's 2 of them, the 2 bottles of rug shampoo. So in total, S of X, if I calculate it, I get 28X plus what happens when I multiply 1092 times 2, I'm going to get 21.96. So this is the new function in terms of the days. Okay. So that is the first part. Any questions on how I went ahead and created this linear function? Again, we knew that X represented the days and it said $28 per day. So it's 28X. And then there's $10.98 per rug bottle, the shampoo. And we had 2 of those. So then that's why it's 1092 times 2. All righty. The next part, it says, now we want to evaluate, meaning that X is equal to 2. So it's saying X is equal to 2, so it's 2 days. And you're substituting it into the linear function, S of 2. So you're going to get 28 times 2 plus 21.96. This becomes, so 28 times 2, that's 56. One second here. So 56 plus 21.96, that gives me a total of 77.96. What does this represent? This represents the cost. This represents $77.96 from renting the machine 2 days with 2 bottles of shampoo. That's what this represents. That's the context of the problem. All right, so then if I would do S of 3, then that would be 3 days. What if now you know the days, but you don't know the rug shampoo? Then that would be something different because that would be a function of Y, not a function of X. So it would be another variable. All right. Moving on, a linear cost function models the cost is represented by C of X equals MX plus B. This is the slope-intercept form. So there's this cost function. There's a linear revenue function that's represented by R of X equals P, the price per item, times X, the item. So the price, P is the price per item. And then there's the linear profit. Is also represented by another linear equation, which is profit is revenue minus the cost. So the profit is revenue minus the cost. And we know the cost function and we know the revenue function. So why do we need these three pieces? Because on the next part of the section, we're actually going to start applying them. So let's go ahead and do that. So let's start by reading the problem. Alina is starting a summer business of the power washing home driveways and sidewalks. She will charge $35 to pressure clean a driveway and the sidewalk in front of the house. Her startup cost, that's important, includes her initial purchase of a washer of $330 and a fee of $2 per house she must pay to homeowners association for the use of each house. So we want to start by write the cost function of the power machine. So first we start with what we highlighted. Her startup cost includes her initial purchase of $330. So the cost function C of X would be the power washer of $330 plus the 2 per house. So the 2 times X, where X represents the homes. You're more than welcome to switch the order. So C of X is equal to 2X plus 330. Now, the revenue function represents the revenue. It represents R of X, which is equal to P times X. Well, P is the price. So what's the price that she will charge? She said she was going to charge $35. So then her revenue function, R of X, is represented by 35X. Now, the next question says, write a linear profit function for the power washing machine. So what we know about the profit function, P of X, is the subtraction between their revenue minus your cost, which we know both of these. So if we substitute, R of X is 35X minus, I'm going to use a parentheses, 2X plus 330. And then I'm going to distribute. I need to, so I can clean it up. So I get 35X minus 2X minus 330. That gives me a profit P of X of 33X minus 330. So this is actually your profit function linear profit function. So P of X is going to be equal to 33X minus 330. I went ahead and combined like terms, the 35 and the minus 2X, they both have an X, therefore I get a 33X. And the negative 330 comes from distributing this negative 2, like so. Okay. Finally, we have 2 more to go. How much profit will Alina make if she power washes 15 homes? Now we know the amount of homes she will be power washing, and it's going to be applied to the profit function. So P of X was 33X minus 330. Now I'm going to do the substitution of P being 15. So that's 33 times 15 minus 330. And when I multiplied out, I get 33 times 15. So let's go ahead and calculate that. So 33 times 15, I get 495. So 495 minus 330, 165. So it's gonna profit $165 for 15 homes. That's how much money she's going to be making. And this represents profit for the 15 houses. Because the more that she cleans, the more money she'll get. And then let's look at the next one. Now this one's saying, how many homes must Alina power wash to make 330? Now we don't know the number of housing, but we do know how much money it is. So we want to find the homes. So we know that the P of X is actually equal to $330. We know that. So we're just going to say, okay, well, that's 330 equal to 33x minus 330. And then we want to solve for X. We want to solve for the number of homes. That means we need to isolate our unique variable X. So when I do that, that means I'm going to bring the 330, to both sides. That's going to be 660 is equal to 33x. When I solve, meaning I divide both sides by 33, I get X equal to 20. So in order for me, and remember, what does X represent? Sorry, let me clear this color. It's not really nice. So this 20 represents the number of homes. This is the number of homes Alina must power wash in order to make that desired $330. Okay. So these application problems are very consistent in the format of using that same linear constant cost function, revenue function, and using both of these to create a profit function. Okay, if you have any questions, by all means, reach out. This diagram that's given to you on this side, this diagram that we have here, it just shows the intersection of the two. So there's your cost and there's your revenue. Now, the last piece is we want to create create models using linear regression. So what is a linear regression? We're going to be fitting scatter plot data. So they're not exactly points, but they're kind of scattered around. And then we're going to visually determine whether it fits a linear form. So we're going to be doing that using our TI-84, and you will be doing some activities involving that on Desmos or on Canvas. Your typical Canvas activity will encourage you to do some application problems, something that discusses this topic. So you should expect something for your Canvas activity as usual. So please refer to our modules and our assignments that are listed on our Canvas website. So what we want to do is start looking at question number 12, and it tells us exactly what to do. So first, we have, and I'm going to share my screen. We want to go ahead and input L1 and L2. We want to use the stat button. So what we're going to be doing is we're going to be using this data. So I'm going to keep this data with me. As you can see, I'm sharing my TI-84. This is a free, and I'm going to share this with you. This is a free app on your Mac store for free. You're free. You can go ahead and use this. And when you're going and when you're going to take it on the test proctoring center, academic test proctoring center, they have resources for you too. They have calculators, but just in case, just bring your student ID, make sure you're following directions. Okay. So I begin by doing second list down here. See how there's L1 and L2. So my L1 will be my X value. So I'm going to go back to my data and it's going to be 0, 1. So I'm going to put this next to me while I'm working on it. So let's see here, it's 0, comma, 1, comma, and it looks, might be look a little bit different if you have it, if you have your actual calculator with you. So 0, you have 1, you have, let me open the doc page. Let's see here. Where'd it go? Let me open it again. Okay, so it's 0, it's 1. Let me bring it over so I can see it. 0, 1, 2, 3, up to 8. 0, 1, 2, 3, 4, 5, 6, 7, and 8. And there's a syntax error. That's weird. And then I'm gonna go to L2 list, and then I'll go to L2. And it doesn't let me do it. That's okay. Let me stop this one then. And then let me share a different resource with you that is also really good. Let me go ahead and share that with you. And let me see here. There's also this website that it's called Wolfram Alpha, like this one. And I want to say, okay, well, I want a linear regression. So I'm going to go ahead and input the point. So I'm going to put 0, comma, point. I'm going to use my parentheses 0, comma, 0.5. And there's the reason I'm doing it right like this right now, it's because my calculator is acting funky. But I recommend you always going to your TI-84, and I'll be submitting videos for you to do that. But I do want to walk you through this resource. 1, 1.3, we have 2, 2.9, and then I have 3, 2.4. Making sure that I'm doing it correctly. And then I'm separating my points, 4, comma, 4, comma, 5 and 5, and then comma, open a new one. And then I have 6, 5.4, close it, open a new one. 7 and 7.7. And then I have 8, comma, 8.3, close. And I'm going to say, I want a linear regression using these points, and then I'm going to close it. I specified what I wanted it to do. So there's the data 0, 0.5, 1, 1.3, 2, 2.9. I want a linear model. So there is how it looks like on the graph. And then here is the best fit, 0.996. So usually your TI will approximate this linear regression, and it's going to estimate it to 0.97. So it's 0.97 plus 0.03. So if we go back to our notes, let me share back my screen. So hopefully it's making sense. Let me go back to the iPad where it tells you to first how to apply it. So use your stat button, then edit. It tells you how to list it right there, nice and clear. Then from there, you're going to use the stat button, then calc. You're going to do your linear regression. You're going to pick that, it's number 4. You're going to hit on it, and that's going to give you this. So y equal ax plus b, there's your a, there's your b. And then you're going to actually do your linear regression fit. So when you do the data, you're going to click on stat plot on the top, and then click on yes on, and then color blue or whatever color you want. And then it's going to do it for you. And then it's going to color in your function there. Okay. So for us, which is the same, we went ahead and used Wolfram Alpha. So assuming that if you're doing your homework at home and you don't have a graphing calculator, I suggest you to get one first. A good place to start, we'll go to the thrift store. I've seen graphing calculators on OfferUp. There's free resources there. Make sure that you're checking out your resources and borrowing a calculator or whatnot. Going to the STEM Learning Center, I'm pretty sure that they have them there. So if you need that, please, by all means, reach out. So what I used on this online website is called Wolfram Alpha. So this is a nice resource to have. It's a good calculator as well. All right, so that was the end of section 1.5. We will continue to section 1.6 next. So let's continue. And I'll stop this recording and then I'll record myself again. All right, so let me stop this recording.